Hi there, my name is Puppet Roger Peng, and today I'm going to show you how to create a totally heavy metal 3D interactive rotating skull in R. So welcome to Cooking Your Data with R. We'll need several things for today's program. First, you need a 3D X-ray computed tomography image of a skull. I'll show you how to get one of these. Then, probably this isn't going to be in the right format, so you're going to have to get something like MIPAV, a medical image processing system, to convert it to the right format to read into R. Then, we need probably my favorite R package of all time, RGL, which is the package that connects R to the OpenGL graphics library. Then we're going to need a package to read in the medical image into R, so oro.dicom or oro.nifty will do. Then we'll need another package which will do the 3D isosurface rendering in RGL. So that is MISC3D is my favorite one for doing that. Okay, so let's get cooking. I got the image that I worked with today off the Osirix software site, where they very kindly put out a bunch of example images. So you go to their website, if you just Google search for Osirix and download, it'll take you to this site. And I went down here to the one that is alias name Mannix, mode CT, file size 40 megabytes, and it's a head CT with contrast. So that's what I was working with. It was basically this image right here. I downloaded it and went into the directory, which I'll show you here in a second. Oh, another important thing to note, right up here at the top, all these DICOM files are encoded with the JPEG 2000 transfer syntax. So that's an issue that we'll have to take up here in a minute. So let me just show you the directories I went through. So Mannix again, then here you can just follow. And there you go. So you see a bunch of .dcm files. These are the individual DICOM files. They're each axial slices of the skull. We're going to have to put them all together, and we're going to have to remove that JPEG compression in order to get it into R. So let's look at our files, get rid of that JPEG compression, and export them to a more usable format. So we're going to go up here in MIPAV. I opened up MIPAV, the Medical Image Processing, Analysis, and Visualization software from the National Institutes of Health. I'm going to go to File, DICOM, and DICOM Browser, and then it's already in that directory. In case you were wondering, that temporary directory is something I created, I outputted this file there. Okay, now here's all my DICOM slices. These are these individual files from that directory. I'll click on one and then just say click on Control A to go ahead and get all of them. Here's the image, that first image, that's what it looks like. Okay, now we're going to open it up by clicking this little icon right here. There's our image. Let's get rid of the DICOM browser. Okay, there's our image, and then we can slide through the axial slices by using this slider right here, and this is our skull that we're looking at. Well, not my skull, I'm a puppet, but you know, a skull. Okay, this is what we're going to create the isosurface of. Still got a couple steps to go through. So now we're going to File, Save Image As. I prefer to save it as a nifty file, and the extension for that is NII. MIPAV will guess what to save it as from the extension that you use. So if you just use .NII and save it, it'll give you a couple of options. You want to use all the slices, you want it as a single file, and you click OK. I'm not going to click OK because I already have the file. Then it'll save a file .nii that is your 3D volume contained in one single file that can be read in, and it will have the JPEG compression removed. Let's go ahead and create our plot. It's actually pretty easy from this point onward. So first let's load our library, oro.nifty for reading the file in, RGL, which is the underlying graphics library connection with OpenGL, and then Mist3D, which has the isosurface, the things that make creating isosurfaces a lot easier. Okay, so reading it in is just a function from oro.nifty called read.readNifty. Okay, and then the important thing is you want this reorient to be false, otherwise you wind up with an error. Okay, it's reading in this nifty file. Okay, now let's just look at it in R. So if we do orthographic, which is another oro.nifty function, you can see, there we go. You can see the coronal, sagittal, and axial slices of the image. Certainly if we were to create an isosurface of this, it wouldn't look very good because it includes not just the skull, but all this other stuff. So let's do a histogram of the image. These are just the intensity values of the image. And you see that there's this big bump at very low values. That's probably the background. That's probably just the black from the background. This bump here might be all this gray that was on the interior of the skull. And then the skull's got to be somewhere up here at maybe, the higher end of the histogram, something like that, where the brighter areas are. But let's check. Let's create another image, and then just that's just a copy of the image, and then for every value less than, say, -500, let's just set that to NA, or a background value like NA. And let's just do another orthographic image. And we see that when we do this, it doesn't change much of anything, so that must just be getting rid of the ordinary background. So now let's try it with 500 and see what happens. Okay, that seems to have just gotten us down to just the skull, which is what we want because we want a rendering of just the skull. Now, we might have missed a couple of things like in here, but that will just make it more heavy metal looking, because it'll have all these little bits of like, of noise like being rendered around it. It'll look more extreme. Just trust me on that. Okay, so now we just want to do contour 3D, which will render the isosurface. So we take the image, and that's the main argument, of course. But then this 1 to 512. Let me just show you something with the image. If I just type in image, the 3 dimensions are 512, 512 by 48. So there is one issue in that the 3 dimensions of the array are not equal spatial dimensions. So that's 0.46 millimeters, 0.46 millimeters in 2 dimensions, but then the third dimension is 3 millimeters. So the representation of a voxel going up and down represents more geographic space than it does moving left to right. Okay, so what we do in contour 3D is we say the indices that I'm plotting are 1 to 512 for the x direction, 1 to 512 for the y direction, and then 1 to 48 for the z direction. But because I want them to be scaled up, I'm going to multiply that by 3 divided by 0.46, which will convert the units to the correct thing. So I want to multiply them by about 6.52. So I just multiply these by 6.52. And I'll take that out and show you how things change. In fact, let's do it first with it without that to show you what happens. And then level equals 500. That means just threshold at 500. And fill equals true means you want a filled version of the isosurface rather than a mesh. Okay, so it looks like a solid object. Contour 3D. There we go. And you can see the issue is it's all squashed. I mean, that might be a skull, but it's all squashed, and that's because it's assuming that the actual pixel dimensions from that third dimension are the same as the pixel dimensions from the first two. So let's convert that, let's change that by multiplying it by the correct multiplier and then see what happens. It takes it a minute to render it. Okay, and then we can zoom in or zoom out and lift it up, and that looks pretty good. Now see, this is from the poor thresholding right there, all that stuff. But as I said, that's more heavy metal. Maybe less good image processing, but more heavy metal. Okay, so at this point, the last thing you want to do is probably make it rotate. So here you can operate it with the mouse, zoom in, zoom out, and all this other stuff. But probably what you want to do at this point is make it rotate automatically so you can play some heavy metal music in the background and bang your head while you're doing it. Okay, so let's figure out how to do that automatic rotation, because you're going to need your arms for flailing about rather than working the mouse. Okay, so let's see. If we can do this, there's this function play 3D. That'll spin it. Duration equals 20. All right, there we go. Totally heavy metal.